Welcome. I'm Bill Witte, and I would guess at this point you've either signed up for beginning algebra and it's too late to drop the course, or your channel switcher doesn't work. Either way, I think you're going to find that the next few minutes are going to be a lot less painful than you might have guessed. So let's begin looking at our algebra, and let's start at the beginning. One thing I need to tell you is, if I talk too fast or you miss something, anything we go over in this class, you're going to be able to go to montgomerycollege.edu/algebra, it's easy to remember, on the web, and you can replay any of the presentations that I'm giving you here. You won't get my wonderful voiceovers, but you'll be able to play them at your own speed. So by all means, check out that website. It's easy to remember. Okay, let's get to it. All of algebra is based on this animal, the order of operations. So let's start there. We need to consider that when you look at an expression in algebra, you have two animals, two words that we need to know. One is operators and one is terms. We need to know the difference. Okay? Operators actually act upon things. So here's a times, the plus, the times. Those are operators. They're actually operating, of course. Okay? The things that are acted upon, we're going to call terms, just so we know we're using the same words. Okay? So each of the numbers in this case are terms. They don't have to be numbers, but they are in this case. Okay? Now, let's take this expression and calculate it. I want you to consider, what are we going to have to do first, the addition or the multiplication? Because, I'll tell you what, it's going to matter. In this case, what did we do to get from the first line to the second line? It looks like we added the 5 and the 7 and got 12. Okay? And then if we multiply 12 times 10, we get 120. It looks like we did the addition first there. What if we take the same thing and did the multiplication first? Multiply the 7 times the 10 and got 70, and then added. Well, now we get a whole different answer. So apparently it really matters which operation we do first, because we can't get different answers. Okay? There's only one right answer in math. You're going to find that out. Okay? So the order of operations is something we've all agreed upon, is that from now on you're going to do, when you're confronted with an expression, you're going to do whatever's in parentheses first, then after you've done all the parentheses, you're going to do the exponents. Then after you've done all the exponents, you're going to do any multiplication and division in there. Now, if there's more than one multiplication and division, you're going to work your way amongst those from left to right. Then you're going to do addition and subtractions. Okay? And the last thing, you're going to simplify fractions, and we'll give you examples of that. Okay? Now, as I said, all of algebra is based on this order of operations. So you definitely need to make that almost a part of your body. Okay? You need to memorize it. And I'm going to be coming back to this throughout the whole semester. Okay? So if you wanted to pick something to memorize, the order of operations is it. Okay? So in this example, which one do we do? Which is the answer? Well, we're required to do multiplication before we do addition, if you have memorized your order of operations. So that's not the right answer. We have to do even though it was from left to right in the previous example there, we're going to have to do the 7 times the 10, even though it's not listed first. We're going to have to do the multiplication before we do the addition, and the correct answer in this case will be 75. Okay? Let's look at another more difficult example. Okay? Consider this. Now, what do our order of operations have us doing here? Well, we don't have any parentheses. We don't have any exponents. So they're all done. So what's the next step? Multiplication and and division. We don't have any division. So we'll do our multiplications, 12 times 5 and 3 times 6, and we'll get them. Okay? Now, all I have left is the addition, and we're ready to rock. Thank you. It wasn't quite that hard, though. Okay, let's look at another example. I'm getting a little bit more difficult. Oh! Okay? Well, we're supposed to do what's in parentheses first. Oh, look, I smell parentheses. There it is, the 8 minus 5. So I'll do that first, and that'll become 3. Okay, I don't have any more parentheses. I have them, but I can't do anything. There's nothing left to do. So let's see, what else? The next thing would be an exponent. I did the 4 to the 2th power. That'll be 16. Okay, let's see, what else do we have left? Okay, there's no more exponents. Now I have multiplications to do. I see the 6 times the 3 I have to do, which I did. Okay? Okay. Let's come back up here. Now I have additions and subtractions. Let's do those. 2 plus 18 is 20. 16 minus 6 is 10. Okay? My last step is to simplify the fraction. 20 over 10 will be 2. So I had to have followed the order of operations to do this problem. And there it is. A little bit more difficult. Okay? We've got to get to know this. Now when we plug numbers in for variables, here again we're going to come back and follow the order of operations. Let's put the 7 every place we see an x, and every place we see a y, we'll put a 3. Okay? It doesn't have to be a blue 3, but it helps. Okay? Let's see. I put in the 7 for the x, and every place I see a y. If I see more than one y, then I'll put a 3 in more than one place, as I have done here. Okay? Now the first thing I'm supposed to do is what's in parentheses, but I have nothing to do there. The next thing I do is the exponent. Now note that that exponent, that little 2, only has power over that blue 3. Okay? The reason that is because we do the exponent before we do the multiplication, as the order of operation tells us. That's why we don't get the 2 and the 3 and get a 6. We do the exponent first. Okay? So 3 to the 2th power is 9. Now I've done all my exponents. It's time to do multiplication. There it is, 2 times 9, 18. And now all I have left is subtraction and addition. Which do I do first? Well, when it's on the same level of order operations, now, and only now, will we work from left to right. So you'll do your 49 minus 18, get your 31, and then you'll add your 3, and hi, Mom, there's 34. Bam! Let's look at another one. Okay, in this case, x will be 2. We're going to plug that in, and y will be 4. So let's, instead of in this case, we have to do what's in parentheses first. The 2 times the y, the 2 times the 4 will become the 8. Okay? We had to do that first. Now, I've done all my parentheses. There's nothing else to do as far as parentheses go. Now I'll do my exponents, of which I have 2. The 8 to the 2th power is 64. The 4 to the 2th power, and it's only 4 to the 2th power because I don't do the multiplication before I do exponents, becomes 16. Okay? Now it's time to do multiplication. Don't even think of doing subtraction now. You do your multiplications before you do your additions and subtractions. So we've got 3 times 16, which is going to be 48. And now, last thing to do in this problem is the subtraction. This is getting tough stuff, huh? Hi, Mom.
Wait a minute.
I just wanted to point out to you that that 2 only has power, in this case, over the x. And why? Every time I say y, for the rest of the semester, it's going to be the order of operations is the reason why. All of algebra is going to be based on the order of operations. Okay, so should you get to know them? Yes. Okay? Now this one, how come that 2 had power over the 2 and the y? Because why do we say y? Because the order of operations. Okay? The order of operations in this case has me doing, what do you always do? Parentheses first. So that's why we had to do what's in parentheses, multiply the 2 times the y first before we did the exponent. So here again, the order of operations, if you can learn it and make it a part of your body, will be your guide. Okay? Let's take a look at this. How would we add those two? Use the order of operations. Well, the order of operations tells me to do my multiplication before I do my addition. 5 times x and 2 times y. Well, I can't do 5 times x and 2 times y. So it's done. That's why you can't add unlike terms. Because, what did I say, why? The order of operations. You've got to know. We're not just showing you the order of operations for laughs. Okay? It's going to be the answer for everything in algebra. Okay? There is, however, one exception to the order of operations. Okay? In other words, you don't have to follow it when. And that's a property. You might have seen it before. It's called the distributive property. Okay? A times, if you have something like A times B plus A times C, then you can bring out, we're going to use a fancy word here, you can factor out the A. Okay? You don't have to do, if you would, the multiplication first. Okay? You can factor out. And I'll show you how we're going to use that. Okay? That's the distributive property. Get to know it. Here's another example. 5x plus 5y, if we use the distributive property, we'll be factoring out or dividing out. It has to be something that's the same. Something the same in both. As you can see, in this case, the 5 was the magic thing that was the same. Okay? So if dividing out the common term leaves only numbers, when we take out that magic common term, we're going to have a definition for what we call like terms. Let's look at things and see if we can determine whether they are in fact like terms. Okay? These two babies. Okay? What is the common term here? What's in both 5x and 2x? Is there something? Well, there is. Hi, Mom. It's the x. Okay? So I can use the distributive property, the exception to the order of operations. There's an x there, and there's an x there. Okay? So I can pull it out. And it leaves then only what? Only numbers. Okay? Just the 5 and the 2, which I can then add. Okay? So, in this case, they are like terms. And I can add them together. Okay? Let's look at these two. Do I have a common term? Like the a. Well, in this case, hopefully it's obvious to you. It's the x. Okay? So if I take that x out, it does leave only numbers, the 7 and the 3. So once again, the answer is they are like terms, so I can put them together. We need this exception because this is the only exception to the order of operations. Okay, that's pretty good if you only have one exception that you'll have to remember. Okay? Okay. Let's look at, see if we can find one that doesn't have like terms. Okay? Okay, let's see. Is there anything, it has to be something common to both of those that I could take out? And there isn't. I don't see it. X is not in both. Y is not in both. Nothing I can take out, so guess what? They're not like terms. Get the idea? Okay. Let's take a look at this. These smell alike, don't they, a little bit? I see something in there that's the same. Okay, what's the same? Well, there is a common term, okay, but does it leave only numbers? Okay? X, Y, yep. When I take out X and Y, hi, Mom, it does leave just numbers. So these are, in fact, like terms, so you can put them together. Son of a gun. What about these? Ooh, these smell a lot alike, too, though. Okay? They have a common, something common. Like the A's, they both have a Y. But when I take that Y out, does it leave only numbers? It doesn't. Sorry, Bub. Not like terms. Unlike terms. Okay? So that's it. Can't do it. Okay? So that has to leave only numbers. Okay? What about these bad boys? Let's see. We'll go a little quicker. It does leave only numbers 2 and 8 when I pull out. What's the magic common term? The x to the third. So I can put them together and get 10x to the third because it left only numbers. Thank you. Thank you. Okay, let's work the other way with this distributive property. We can work backwards and This is another exception, remember, to the order of operations, because the order of operations would have had me doing what's in parentheses first, but I can't do what's in parentheses first. The x and 5, I can't do it, but this is the exception. So I can distribute the 3 times x, 3 times 5. I'm distributing it, and I'm going to distribute the 7. 7 times x, and 7 times negative 1. You integer majors know that's negative 7. And now, at this point, I can add like terms. Okay, I hope by now you get the idea of like terms. The 3x and the 7x will become 10x, and the 15 and the minus 7 become a plus 8. Okay? Now you can think of that minus at the 7, by the way, as either a negative, 15 and negative 7, or a subtraction. Either way, but not both. Okay? Yeah, really, thank you. Okay, let's look at this bad boy. Ooh, this is a little bit more difficult. I'll show you why. Okay, we're going to distribute that 2. So we're at 2 times x, and 2 times, 2 times what? 2 times, I'm going to think of it, you can think of it however you want. As a negative 6, I think it's going to be way easier to think of it as a negative 6, or minus a 2 times 6. I like to think of it as 2 times minus 6 and get my negative 12. Okay? Now the next thing, I could do subtraction, but there again, I like to think of that as a negative rather than a subtraction. I'm allergic to subtraction. So you can think of it however you want. Okay? It's the same sign on the typewriter, right? On the computer. Okay, so I'm going to think of it as a negative 5. Negative 5 times x will give me the negative 5x. And negative 5 times negative 1, negative times a negative, it's a positive, right? Okay? Okay, once again, we'll add like terms. Let's see. 2x and negative 5x, I get more negative than I got positive, so the negative's going to win here. Negative 3x. And negative 12 and positive 5, here again, I got more negative than I got positive. It's like my bank account. Okay? And that's it. You gotta love it. Okay? Okay. Let's move on to solving equations and see how the order of operations, once again, is key to this whole schmeal. Okay? Well, let's look at this, an equation. What could x be? What could you make x to make this true? Okay? I bet you know. 2. You did it in your head, right? X is 2. Now, do you see what I mean when I say x is by itself? It's sitting there by itself. So it's telling me I am 2. So it's simple. You just read it. X is 2. Okay? So our goal is going to be, whenever we solve these equations, to get the variable, whether it's x or y or whatever, by itself. So you see what I mean. Okay? What would make this baby true? We want x by itself. Okay? You may not be able to do this one in your head, huh? Okay? Well, let's see. What's keeping it from being by itself? That's 6.5. That equal sign is like a giant scale. Okay? So it's going to be important when we're trying to get x by itself, whatever we do on one side of the equal sign, like a giant scale, whatever we do on one side, we're going to have to do on the other. Okay? Let's take a look. We got x plus 6.5 on one side of the scale and 8.3 on the other side. Okay? So in this
Wait
case,
a minute.
I'm going to add negative 6.5 to undo the positive 6.5. Okay? But I have to do it on the other side, or it's not keeping the scale even. That'll get rid of that. X will be by itself, and 8.3 minus 6.5 is 1.8, and x is by itself, so I've finished the problem. So I'm basically undoing whatever it takes, or doing whatever it takes to get x by itself. Okay? Let's try this. What are we going to have to do to get rid of that minus 14? What's the opposite of subtracting 14? Well, we got a scale here.
Uh-oh.
I had to add 14, but if I do it on one side, I have to do it on the other. And that'll get rid of it there. And once again, I've got x by itself. And that's how you do it. Okay? Now they get a little bit more difficult than this, but let's just take a couple more examples. We have to remove the 3. Now in the 3, in this case, you have to say to yourself, what is the 3 doing to the x? And what I mean, what is he? Is he adding, subtracting, multiplying, or dividing? Well, as you can see, he's multiplying. So I'm not going to subtract 3 in this case. I have to do the exact opposite of what it's doing. It's multiplying, so I should divide. Okay?
Wait a minute.
That's right. If I'm going to do it on one side, I certainly have to do it on the other. Okay? So 3x divided by 3. Hi, Mom. I've gotten rid of it. Well, 3 divided by 3 is 1. We really don't need the 1. 1x is x, right? And 33 divided by 3 is 11. So there it is. He's by himself again. Ding-a-ling. Okay? Let's solve this bad boy. Oh, now here's where we got a problem. Okay? Who's keeping x from being by itself? 2 things. The 3 and the 7. Which do I get rid of first? Order matters. Remember. Oh, we're talking about the order of operations again? Of course. Okay? Well, let's see. What you need to know, when we do a problem, we follow the order of operations. You need to know the order of operations so well. Do you know what? That you need to know it forwards and backwards. Because right now, we're not doing a problem. We're undoing a problem. Okay? So when we do a problem, we follow them forward. When we solve equations, we're undoing a problem. We're going to follow them backwards. We're going to simplify a fraction, undo that, undo addition and subtraction, undo multiplication and division, and kind of undress the variable. Okay? Work our way backwards. So you do need to know this forwards and backwards. Let's take a look back at that problem then, where we had multiplication and division and addition and subtraction. In this case, to undo it, we're going to undo the addition and subtraction first. So we're going to get rid of the 7 first.
Wait a minute.
How to do it on both sides. Okay. That got rid of that one. Okay. Now, and only now, we'll get rid of that 3. Now, what is the 3 doing to the x? It's multiplying. So we'll divide, but
wait a minute.
we got to do it to the other side, Junior. And there it is. X is 12. Okay? So it really matters what order you solve these things. Okay? Really. Thank you. Okay, let's try this bad boy. Which do we have to get rid of first? We're going to do the order of operations backwards to undress this b in this case. Okay, I've got 2.6 multiplying, and I've got 5.2 subtracting. Okay, the order of operations backwards now tells me to get rid of the subtraction. So I'll add, doing the opposite operation.
Wait a minute.
Oh, we got to do it on the other side. There we go. Okay. I'll undo. I needed a calculator. I'm not that good at this. Okay. Let's see. Okay. Apparently they add up to 23.4. Now, 2.6. What's he doing to b? He's multiplying. Okay. So I'll divide.
Wait a minute.
Okay. I have to divide the other side. You've got to be fair. Whatever you do to one side, you do to the other. Okay. I need my calculator. Divide 1b, and oh, what a coincidence. It comes out exactly to 9. Doesn't always come out, but it could. Okay, so there's your answer. B is 9. Life is good. Okay, oh, this one's tough. Now in this case, I need to get z alone. But which z do I get alone? Okay, well, I can do anything I want here, really. You can't screw up as long as whatever you do to one side, you do to the other side. Okay? The first thing I'm going to do, however, though, is I'm going to combine like terms. Okay, I see this 42 and this minus 5. And I don't need to do that to the other side because I'm not adding or subtracting or actually acting upon that side. I'm just adding like terms. So I'll add them up. They become 37. Okay? Now in this case, let's see, what do we got going here? As long as I do something to both sides, I'm going to try and make the two z's get together in some fashion so that I can get one of the z's alone. Okay? Let's see. I'm going to subtract 3z from both sides.
Wait a minute.
Oh, got to do it to the other side. Okay, let's see what that does for me. Okay, that got rid of the 3z on that side, and the 2 combined to minus 5z. Now I've got one to get alone. I'll get rid of the minus 5 and get rid of the 7. Remember, I get rid of the Order of operations backwards. I get rid of the addition first. So I'll subtract 7 and subtract 7 there. Now I'll get rid of the minus 5. I'm not going to add 5 here. Why? Because the minus 5 isn't subtracting, it's multiplying. So I'll do the opposite operation, which is division. Both sides. Hi, Mom. There it is. Z is negative 6. This is the big leagues now. Okay? Now I want to look at that same problem, and I want you to consider something. Okay? Basically, the first step, we combined like terms. Okay? Now, at this point, the next thing we did was we subtracted a 3z to both sides. Another thing we could have done, people say, all right, I got to do just what he did. You don't have to. You could have added a 2z to both sides. As long as you do it to both sides, you're going to be hunky-dinky. Okay? And my suggestion is, when in doubt, it doesn't matter as long as you do it to both sides, bring the smaller over to the bigger. Okay? In this case, it doesn't matter, but it's going to be easier because in this case, I didn't get a negative. Okay? And I'm allergic to negatives. Okay? So if you have your druthers, if it doesn't matter, and it doesn't, rather than bringing the 3z over to the minus 2, bring the minus over to the plus. It makes life easier. Okay, anyway, let's get rid of this 37. Both sides. Now, it's going to help in class if you actually say uh-oh every once in a while, okay? So that make sure that you do it to both sides. I see people in the assessment center on the test going, uh-oh, make sure you do it to the other side, okay? The assessment center people love that. Okay, now what else? We have to get rid of that 5, which is multiplying, so I'll divide. Other side. There we go. We are mean, lean, solving machines. Bam! Okay, it doesn't matter which you move as long as you treat both sides the same. Okay, and as I said, it's going to be a lot easier, not that much easier, to bring the smaller over to the bigger. Okay, let's look at inequalities. Okay, things are unequal. Well, inequalities are when they're not equal. Okay, let's graph this. X, I want all the x's where x is, that's red, greater than or equal to 3. So I'm supposed to put a dot everywhere where everywhere where there's a number that's bigger than or equal to 3. Should I put a dot? Is 5 bigger than or equal to 3? Yeah. We'll put 1 on 5. Okay? Is 8 bigger than or equal to 3? Hunky dinky. We'll put 1 there. Okay? And you want to go through all the points. Is 1 bigger than? No. Don't put 1 on. No, we're not putting a dot. Only put a dot where it makes it true. Okay? What did I miss there? Well, 3 is bigger than or equal to 3, so we put that on there. Okay? Is 6.5? We've only been doing integers here. 6.5. So the ones in the middle are also. Okay? So we're going to do a whole bunch of them. Basically, if you put all the points, they all basically connect, if you would. I don't want to stay here all the time and do one at a time. Okay? And consider also that 102, which you can't even see, is also bigger than 3. Oh, there it went. Okay? So to represent that, we put the arrow. Because it goes to infinity, basically. So that's what the graph looks like for x is greater than or equal to 3. Let's look at x is less than 4. It's a little bit more difficult. Is 5 less than 4? That should be a 4. No. Is 2 less than 4? Yes, it is. There he goes. Is negative 1 less than 4? It's a negative, but it's still less than 4. Okay? Is 1.25, somewhere in the middle there, less than 4? Yes, it is, so we'll put that in. It's about at 1.25. Okay? Is 4, now this is important, is 4 less than 4? No, it isn't. So we don't put a dot on 4, but there's going to be things that are very close to 4 that are less than 4. Okay? So what we do is put a circle to say all the numbers very close to 4 are less than it, but not 4. So whenever you have a less than or a greater than, in other words, there's no or equal to, you're going to have to put a circle because you don't want a dot going on that endpoint. Okay? And of course, there are numbers off the picture that we're going to have to represent. And we remember how we do that. We use the arrow. Okay? So in summary, when we have a greater than or equal to, or less than or equal to, we're going to have a solid circle. like that, or a dot if you would. Okay? And when we have a less than or a greater than, it's going to be an open circle. Okay? Don't include the endpoint in that case. Okay? Let's take a look at this bad boy. Now this is a kind of two at the same time. I want to graph all the x's that are both greater than 0. The mouth is opening to the x. Now note that I could read that 0 is smaller than x. Okay? But we're graphing x. So you always say the x first. Now the mouth's opening to the x. So I'm going to read this. X is greater than x. X is greater than 0. Okay? And that's going to look like that. Note that I don't have a dot. It's a circle. Okay? The other part of it is where is x, I'm reading x first, smaller than or equal to the 5. Now the mouth's opening to the 5, so the 5 is bigger, so the x must be smaller. You're either smaller or bigger. Okay? So I want all the numbers that are smaller than or equal to 5, and they're going to be there. Now where are dots that are on both of these graphs? Okay, where are they both true? And you see this area where it's going to come down? It has to be on both parts. So basically, the graph of that is going to look like that. Okay, and that's what I'm going to ask you to do. Okay? And you can break it into steps like I did if you want, or if you're Einstein, you can go right to the answer. Okay? Oof. Now this is not an and. It doesn't have to be in both of them in this case, as long as it's on one of them. As long as it's either smaller than or equal to -1 or bigger than 6. Okay? Now there's your x is less than or equal to -1. Note that I filled in the dot. And our x is greater than 6 is going to be that one. And actually, that's going to be the answer. Okay? Because as long as it's on one or the other, we're golden. So the answer to this is going to be like that. Okay? Now, how are we going to graph this? Well, we can't graph it until we solve it. And how do we solve it? How did we solve equalities? We worked our way backwards through the order of operations, getting the variable by itself, and that's what we're going to do here. Let's see, who's keeping it from being by itself? Well, the 3 and the 7. Why am I getting rid of the 7 first? Because I do the order of operations backwards. The order of operations tell me to do multiplication before I do addition, but this time I'm going to work backwards because I'm undoing it. So I'm going to subtract a 7
Wait a minute.
from both sides. Okay. Let's see. So 3x is greater than 36. Now I got to get rid of that 3. He's multiplying, so I'll divide.
Uh-oh.
Got to do it to both sides, Junior. Okay, so x, or 1x, is greater than 12. Okay? Now, I've got it solved. X is by itself. It's time to graph. Don't clap just yet. Where would we graph x is greater than 12? There's 12. You can fill in all the other numbers if you want, but the important thing is that would be the graph of that truth set. Okay? Okay. Now there's one difference between what I would say a regular equation, one with an equal sign, and these inequalities. Okay? Consider this. How would we read this? 4 is smaller than 8. Okay? That's true. Or 8 is bigger than 4, however you want to look at it. Okay? It's true. What if I add 2 to both sides? I'm allowed to do that as long as I do it to both sides. It's true. 4 plus 2 is 6. 8 plus 2 is, in fact, 10. Okay? Everything's hunky-dinky here. Now watch. Hold on. It's going to get fancy. What if I multiply both sides? You know, if you spit on both sides, as long as you do anything on both sides, you're going to be okay. If you spit on one side, spit on the other. Okay? Whatever you do. Okay? But in this case, I'm going to multiply both sides by 2. 6 times 2, 12. And 10 times 2 is 20. And son of a gun, 12 is still, what I'm trying to show you is the blue equations still hold true. Whatever I do to both sides, as long as I do it to both sides, the equation remains true. 12 is still smaller than 20. Okay? Well, wait a minute. Remember what I told you, as long as you do something to both sides. Okay? What if I divide both sides? It seems reasonable. What if I divide both sides by a -4? Negatives. What's 12 divided by negative 4? Negative 3. What's 20 divided by negative 4? Negative 5. Well, who's bigger? Negative 3 or negative 5?
Wait a minute.
Oh, negative 3 is not, think about it, negative 3 is not smaller than negative 5. So we have to, when that happens, whenever you divide by a negative number, all the rules are off. There's going to be another thing you're going to have to remember. You can use all the same rules when solving an inequality, a greater than or less than equation. But if you divide by a negative number, or as a matter of fact, if you multiply both sides by a negative number, you're going to have to, as you can see, switch the sign. Okay? Which is why earlier in the show, I was showing you there were two ways to do that one problem. And I was saying, bring the smaller over to the bigger, since it doesn't matter which way you do it. Bring the smaller over to the bigger. That way you won't get any negatives. You don't got to worry about it. Okay? But if you do get negatives, when you divide by a negative number, of course you'll do it to both sides, you will have to switch the sign. Okay? Okay, let's try this one. Well, let's see. This looks a lot like something I had done before. Let me add like terms. The 42 and the minus 5. Okay, I'm just combining them. They become 37. I've seen something like this before. Now, in this case, the way I'm going to do it here, I'm going to subtract a 3z
Wait a minute.
from both sides. Okay? That wasn't the wisest thing to do, but it's legal. As long as I do it to both sides, legal smeagol, I can do it. Okay? Now, I got to get this z by itself. Who do I get rid of first? Well, I'm going to get rid of, you may remember, the 7. I'm going to subtract a 7 from this side.
Wait a minute.
Thank you. You need to subtract it from the other side. Okay? Let's see. I got minus 5z is greater than 30. Now what do I have to do to, quote, get z alone? Well, who's bothering him? The minus 5. What's he doing? Multiplying. So I do the opposite.
Go.
Uh-oh. It's a negative. So if I divide by a negative number,
Wait a minute.
that's okay, but I have to switch the sign. If you divide by a negative number, you have to switch the sign. The reason we switched this is because we were the troublemakers. We introduced the negative to the problem. Not because it was already there, but we introduced a negative into the problem. Okay, so let's compute this. Negative 5z divided by negative 5 is in fact z. Note that I switched the sign here, and 30 divided by negative 5, just basic computation, is negative 6. So the answer to this problem actually is z is less than negative 6. Okay? Thank you. Okay, let's take the same problem, though, and do it in possibly a more strategic way. Okay? Once again, we're going to combine our like terms. Get our 37. Now at this point, instead of subtracting a 3z, I'm going to add a 2z. As long as I do it to both sides, I'm hunky-dinky. Okay? Why am I doing it this way? Because this time, if I bring the smaller over to the bigger, I say the smaller. Negative 2 is smaller than 3. Okay? So I'm going to act upon him. It's like beating somebody up. I always beat up the smaller guy. It's easier. Okay? Anyway, let's get rid of that minus 2z by adding a 2z. Got to do it to the other side. Okay? Let's see what I get here. The minus 2z is gone, and I get 7 is greater than 37 plus 5z. Well, now, let's see. I've got to get rid of that 37 and rid of the 5. Just like all my other equations, which do I get rid of first? Remember, you're going to get rid of, follow the order of operations, which you have memorized. You're going to get rid of the 37 first, because we're undoing the problem. Got to do it to both sides. Okay? Ouch. What is 7 minus 37? Minus 30. Very good. Okay? And that I just bring the 5z down, note. Okay? Now I got one more thing to do. Who's keeping z from being by itself? The 5. What's he doing? Note that, by the way, I'm going through the, who's the troublemaker? What's he doing? I'll do the opposite. I'm always going through those three. Who's the troublemaker? What's he doing? I'll do the opposite. Okay? Very much like playing Pokemon. Who do I have to face? What are his strengths? Let me find his, or what are his weaknesses? Let me, work against those. Okay? If it's somebody that freezes, I'm going to bring in heat. If it's somebody that blows, I'm going to suck. Okay? Whatever. Okay? So in this case, I got to get rid of the 5. What's he doing? He's not adding. He's multiplying. I'll divide. Okay? Now, in this case, this is a little bit different. I didn't have to switch the sign. That's what I was trying to show you here. People go, well, how come you didn't have to switch the sign there? There was a negative 30. That negative 30 was already there. Okay? When you have to switch the sign is when you're dividing by a negative. When you're the troublemaker. When you're introducing negative into the problem. I didn't introduce negative into the problem here. Did I? I divided by a 5. Okay, so I don't have to switch the sign in this case. Hopefully you see the difference. And I've got, this would be red actually, because you always read the letter first, because that's what I'm graphing, would be red. Z is less than negative 6. Okay, the mouth is opening to the negative 6, so he's bigger, so the Z must be smaller. Z is smaller, or Z is less than negative 6. So as I say, you don't have to always do this. The thing to remember is whatever you do to one side, do to the other. But if you always bring the smaller over to the bigger, you're not going to have to worry about any negatives. Okay? It's a good strategy to use. Okay. Now just in case you fell asleep, we're going to go over all this, just a basic review of everything we've covered up to this point today. Okay, let's take a look. The order of operations in order to do a problem, or you're going to do what's in parentheses first. You're going to do any exponents that are involved, followed by any multiplication and division. If there's more than one multiplication and division, that's the only time you're going to work from left to right. Then you're going to do your addition and subtractions. Okay, which people usually want to do first because they're the easiest, but you're going to hold on to that and work your way from left to right if there's more than one. Okay, and then last thing you're going to do is simplify any fraction. Okay, that's when we're doing a problem. Let's look at an example that we saw earlier. Okay, in this problem, we have a whole bunch to do. We have addition, we have subtraction, we have exponents, we have fraction, we have all kinds, we have multiplication. Which do we do first? Order of operations tells me I have to do what's in parentheses first, which is that 8 minus 5. So I'll compute that, not do anything else. That leaves the 3. Okay? Now, what's the next thing to do? Any exponents. I see an exponent with the 4. 4 to the 2th power is 16. Okay, so I've done my parentheses, then my exponents. I have no more exponents. It's now time to do any multiplication and division. I see a multiplication, the 6 times 3, which I will compute now. Okay, I've done all my multiplications. Now it's time to do additions and subtractions. You know I have 2, so I'm going to do the, my left to right or top to bottom, wherever you want to look at it. I'm going to do the addition first and get the 20, and do the subtraction, 16 minus 6, and get the 10. The last step in my order of operations is to simplify a fraction. Remember that a fraction is basically the top divided by the bottom. Okay? I could write this 2 over 1 or just 2. Okay? That's to do a problem. Now make no mistake, when we're solving an equation, we're not doing it, we're undoing it. Okay? So let's, we don't want to get confused with this. So when we're solving an equation, when we're undoing a problem, we're going to follow the order of operations backwards. Okay? Which means we're going to simplify or undo any simplification of a fraction. Basically, we're going to be getting rid of fractions. Okay? We're going to undo any addition and subtraction. We're going backwards with the order of operations here. We're going to undo any multiplication and division. We're going to undo any exponents. and we're going to work our way into parentheses. So we're going to go backwards of that. Now what would be an example of that? Let's look at an equation. Let's see. In this case, I have two things to get rid of. I have to get rid of, to get that b alone, I have to get rid of the 2.6, which is multiplying, and I have to get rid of the minus 5.2, which is subtracting. Okay? To follow the order of operations backwards, it tells me to get rid of the minus 5.2. Now, how do I get rid of a minus 5.2? I add 5.2.
Wait a minute.
Remember, anything you do to one side of an equation, if you remember only one thing from this class, whatever you do to one side of an equation, do it to the other. Okay? Note that it's going to help to line these things up, by the way, so that you can see that you're doing it to one side of the equation. The equal signs should always line up sweet and neat like this. Okay? So that got rid of it there. Do a little calculation here. Look how those equal signs line up. I could just kiss them. Okay? 2.6b equals 23.4. Now I got to get rid of the 2.6. What is it doing to the b? It's multiplying. So I'll do the opposite operation. Divide. Okay?
Wait a minute.
All right. Whatever I do to one side, I have to do to the other. Okay? I'm going to take a little bit of calculation. I'm not going to review how to divide decimals. Okay? If you have trouble with that, go back to your pre-algebra. Okay? And 1b, or b, equals 9 in this case. Okay? So that's the difference depending on what order you're following. You found the order of operations to do a problem, and you do the order of operations backwards to undo a problem. Okay? We also covered graphing inequalities. You may remember the endpoint summary. When we have greater than or equal to or less than or equal to, we have a solid circle, basically a dot. Okay, because that means we want to include the endpoint. And we have a less than or a greater than, meaning not equal to, if you would. Okay, we're going to have an open circle, okay, or an open dot, if you would. That means we don't want to include the endpoint. Okay, how is that involved? Well, let's take a look. We did a problem something like this. Graph the truth set of basically two problems, kind of. This would be read, x is greater than x. X is greater than 0. How would I graph that? Note that it is an open circle because it's not or equal to. Okay? And x is less than or equal to 5 would go there. Okay? And in this case, I'm looking for all the parts of the graph that are on both lines, both graphs. Okay, where are they both true? And that was this area here. Okay? Okay. And we covered, the last thing we covered was solving and graphing these inequalities. And basically you were doing the same thing, solving it, you know, getting x by itself. In this case, I'm going to subtract 7 to both sides.
Wait a minute.
I said both sides, Buford. Okay. Let's see what we get. A 3x on that side. Here again, note where I was lining up the equal signs. Now I'm lining up the greater than, so that I can see whatever I did on one side, I did on the other. Okay? Neatness counts. Okay? Now, the 3 is multiplying, so I'll divide. Divide both sides by 3. And I get x is greater than 12. Remember how that would graph? I would put, in this case, a circle on 12 and go to the right. Bam! Okay? Well, at this time, it's time for you to do the work. I'm done. Okay? So go do your homework, use your software. If you have any trouble, don't forget that you can go to the home page. It's easy to remember, and you can review what I've just shown you at www.montgomerycollege.edu/algebra. And by the way, if you have trouble with your decimals or anything else not related to algebra, more to pre-algebra, there's another site montgomerycollege.edu/pre-algebra. Okay? But to review what we've covered in this show, you'll go to this website. Thanks for watching. See you next time, and do your homework.